Hello everyone, this is Mrs. Lim, and in this video, we will be introducing on Chapter 11, General Wave Properties. So in this first part of the videos, we will be talking about how do we describe wave motions. Okay, specifically, we will talk about what is meant by wave motions, as well as how can wave be illustrated in vibrations in ropes, springs, and ripple tank. Okay, and then we also show an understanding what it means by wave transfer energy without transferring metal. So what exactly is a wave? A wave is a disturbance that transfers energy from one place to another. Specifically, it transfers kinetic energy from one place to another. Okay, and all waves are made out of periodic motions. We will explain in depth what it means by periodic motion later on in the video. Okay, so the first example is water waves. Water waves are generated whenever there is a source of disturbance. For example, you can see over in this picture, there's a drip of water dropping into the still water surface. So this drip of water is actually creating a disturbance. So it creates a water wave. Okay, we can also generate water wave in a ripple tank that looks like this at the bottom. It's just a glass container, which is transparent at the bottom. And then you just shine light through it. And you have a wave generator, which is a motor that constantly dip this spherical dipper into the water, up and down, up and down, up and down, and then it will produce circular ripples, or we call it circular wave fronts. And then these wave fronts can be analyzed by shining light onto it, so it will project dark and light areas. Okay, so that is a ripple tank. It can produce water waves. And then another type of waves that we can produce are rope waves. So how do I generate a rope wave? So I introduce a source of disturbance, which is my hand. My hand can move up and down. Okay, so this is my source of disturbance. And then this disturbance will generate a wave. And the wave will always move away from the source of disturbance. So my source of disturbance is here. It will move away from it, okay, to the right side until you reach the fixed end of the wall. So this is the direction of propagation of the wave, or direction of travel of the wave. Okay, just take note that in this case, when I move the rope up and down, okay, my motion, my vibration of my particles, my wave particles, or my rope particles is perpendicular to the wave motion. You can see that the direction of vibration is up and down, and the wave motion is to the right. Okay, the rope is the medium through which the energy, the kinetic energy from the hand gets transferred. Okay, so if you are standing at the other end and holding on to the rope at the other end, you can feel the vibration in the rope because the kinetic energy of the hand gets transferred through the rope, the medium, to the other end. Okay, but the rope doesn't, at this end of the rope, it just stay on the spot and vibrate up and down. It doesn't get moved to the other end. Okay, the next one. Okay, besides using your hand, you can also use a wave generator. So this diagram shows a wave generator. So this wave generator will move up and down to create this disturbance. And again, the wave travel will be away from the disturbance. Okay, so the wave travel will be in the blue arrow. Okay, A and B are particles on the wave. Okay, so these particles on the wave just stay on the spot and vibrate up and down. So as it moves up, okay, it pulls along particle A, and particle A will again pull along particle B to move up. And when the dipper moves, the wave generator moves down, okay, it pulls along, so particle A will pull downwards, B will also be pulled downwards. So it will form a series of up and down motion, which is known as your wave. Okay, so there is a video on this. You can take a look at it. So I'm not going to play the video. Okay, so this is a guy. He's playing with rope waves, so he's moving up and down. So the particle motion is like this, and then the wave is moving away from the source of disturbance, moving from here to here, and then he ties the other end to a pole, and you will see that this pole will start to vibrate as well. So the energy, it shows that the energy from him actually gets transferred through this rope to this rod over here, cause this rod to move. Okay. Next, okay, you can see that so segment A and B do not move. There is no transfer of matter. Okay, and the motion is described as periodic because after moving up and down, it will always return back to its original position. That's why it's called periodic motion. So in general, a wave is a disturbance that propagates through space, transferring energy with it, but not matter. Okay, I'm going to pause here and I'm going to show you some videos. What does it mean by it transfers energy but not matter? Okay. Okay, so over here you can see that I have a video about this man. Okay, so he is creating a source of disturbance by his hands moving up and down, and then we zoom into the particles in the rope. Okay, the blue particles as well. We just zoom into one of them, which is the orange particle. You can see that the particles just stay on the spot and vibrates. That is what I mean by it transfers energy, specifically kinetic energy, but not particles. Particles just stay on the spot and vibrate. Okay, next one. Okay, we have a water wave that I mentioned. Okay, so let's zoom into it. So again, I have a drop of water. Okay, I drip it in, it introduces a source of disturbance. And then if I look at the particle, I just look at one single particle over here. Okay, the particles just vibrate up and down. Okay, and then the wave travels outwards. Okay, to the left and to the right, outwards. Okay, from the source of disturbance. Okay, then let's go back. So this is what I mean by a wave is a disturbance that propagates through space, transferring energy, but not matter. Okay, so there are other ways. Instead of always moving up and down, okay, I can also make a wave by in a slinky coil, for example. I can move up and down the slinky coil. I can also move the slinky coil by pulling and pushing it. Okay, so by pulling and pushing it, in this case, I am creating a disturbance. So my wave will travel away from the disturbance. So my wave direction of wave travel will be to the right. Okay, but now my direction of vibration of the particles will be parallel to my direction of the wave travel. So this is another type of wave that I can create. Okay, in the second part of the video, I will mention about what is the difference between these two waves. It's called a transverse wave, and this is a longitudinal wave, whereby the direction of vibration is parallel to the wave. Similarly, if I were to pull and push here, okay, if the other person were to hold this fixed end, the other person will feel the tug on the slinky coil because energy gets transferred. But the slinky coil, if I were to zoom into just particle ABC, particle ABC just stay on the spot and vibrate left and right, left and right. They do not get transferred. The slinky coil A doesn't get moved all the way to the other end. Okay, so similarly, you can watch this video on yourself. So if we focus on just a single segment like A, you will realize that they are in periodic motion. It moves to the left, right, and back to its original position, left, right, and back to its original position. Same for B and C. Okay, so in summary, examples of waves, there are water waves, rope waves, spring waves, okay, and waves are all disturbance that propagates through space, transferring energy with it, but not matter. And then we observe that the motion at any one point is always periodic and repetitive. And this motion is known as a vibration or an oscillation. Okay, I will stop here and then I will show you the slinky coil example again. Okay, so I'm back to this video. So over here, I have a slinky coil. So you can see that I just move my slinky coil left and right. You can see the wave will start traveling. You can see this power over here, follow my mouse. Okay, so the wave is moving to the right. Okay, and then if you were to take a look at just one single coil, okay, this purple coil is a periodic motion. It moves left, right, left, right, and you're always back to the original position. The original position is the line over here. Okay, so if you were to trace, you will see this. left, right, back to original position, left, right, back to original position. Okay, and then the graphical format, we will go through in the second part. But just to let you know what happens to the particles, if I were to trace it out, it should look like this. Okay, so that's all for the first part of wave introduction.